after step 1 and 2, we have converted basic entities into relations. So now we have several relations at hand in order to take care of the relationships or the foreign keys in the relational schema diagram. We now want to take a look of step 3, 4, and 5 that handles our relationships. Since in cardinal ratio, there are only 3 different types of cardinal ratio indicating 1-to-1, 1-to-n, m-to-n relationships. Those are 3 different types corresponding to step 3, 4, and 5. So let's take a look of step number 3, working on 1-to-1 relation. For each binary 1-to-1 relationship type in the ER schema, identify the relations S and T, indicating that the relationship connects 2 entities. We want to find those 2 entities, and then that corresponding to the entity types participate in R. And then what we want to do is that we want to choose one of the relations, say S, and include a foreign key in S, the primary key of T. What that's trying to say is that that relationship will convert into a foreign key. Since it is a 1-to-1 relationship, both and is fine. You can use the S side of the primary key, put that in T side, and use a foreign key to link them, or vice versa. However, it is better to choose the one if there is one that represents a total participation. It's probably not very easy to understand. Let's take a look at an example to understand it easily. So you see that in this ER diagram, we already have 1-to-1 relationship, which indicating employee manages department. Department is managed by one employee, and we have a partial and a total in this relationship over here. So again, since this is a 1-to-1 relationship, there are 2 choices you have. Let's take a look of the first choice. The first choice is going to use the employee side, take the other side's primary key, which is indicating the D number that we have. We take the D number, come in here, make a foreign key links to the department. So you can see that it is like we change this relationship, become a foreign key in the employee, and link that to the department entity. And therefore, what you can see is here. Since there is one attribute attached to this relationship, while we do the conversion, we still want that attribute to be included, and therefore we will end up with taking a foreign key and an attribute of the relationship, forming a foreign key that links to the other side over here. So this is choice number 1. Since we mentioned that there are 2 choices, and I want to tell you why this choice is less ideal. Think about this, because this is a single line indicating that not every employee participates in this relationship. While we're doing this, you can see that maybe we have 8 employees, only 3 of them are managers. So what happened to the other 5 employees? They will end up with null values over here. So that is what's happening if we take the partial side to create this conversion. It is correct, but this is probably not optimal. Let's take a look of the other choice. The other choice is that we take this relationship, become a foreign keys to the double side, a total participation side. And then you can see that we take the managers come in here. So we would take the primary key over here and name it as manager, SSN, indicating who is the manager of that, and form a foreign key, go back to the primary key of the other side. Again, if you are creating a foreign key, the arrow must point at the primary key of that table. Therefore, you can see we will create this manager social security number. The start date will come together with that and then form a foreign key point at the primary key of the employee. Think about this. because this is a double line indicating every department must have a manager. And therefore, if I have 3 departments, all 3 of those will have values for their managers, because every department must have a manager, says by this double line over here. And therefore, this is a much better choice than the other one. And that's what we are talking about. When this is happening, we will want to create a one-to-one relationship into a foreign key, goes to ideally the double line, which is the total participation side, form a foreign key links to the other side. And therefore, this is our step number 3. Step number 4 is the next type of the relationship, indicating 1-to-N relationship. This one uses a very similar concept that you have just learned in step number 3, using what we call a foreign key technique to solve this relationship. So for each regular binary 1-to-N relationship, identify the relation as that represent the participating entity type at the N side. Now, instead of 1-to-1, which you have choices, you can go to one or the other one. For 1-to-N relationship, you have only one choice. You can only use the N side to do the foreign key technique, indicating that you create a foreign key on the N side links to the other side's primary key. What this will need to do is include as a foreign key in S the primary key of the relation T that represents the other entity type participate in R, include any simple attributes of this 1-to-N relationship type as attribute of S, indicating if this relationship has some attributes, you also need to convert that into the N side. There are several examples in our ER diagram, more specifically 3 of those, including one recursive relationships and another regular 1-to-N relationship. Let's start taking with the supervision. So you can see that in this supervision, what it tried to do is that indicating every employee must have some supervise. Since it goes to the same entity, while we're choosing the N side, it will go back to the employee entity itself. So what's happening is that in the regularly, we already have the employee attributes that are coming from our step number 1. First name, middle name, last name, social security number, birthday, address, sex, salary. So you can see that until step number 1, we have get all of these attributes. Now, in order to handle this recursive relationship, we create a supervisor social security number that goes back to the employee. So you see that we create this additional attribute, create as a foreign key that it will link back to the primary key of the other side, which still employee. And therefore, you can see that is a supervisor goes back to the social security number, which is the primary key of the employee. That is how we're going to convert our very first 1-to-N relationship. The other one is the works for, indicating that each employee must work for one department. On the other side, each department has several employees works for them. So we have this 1-to-N relationship that we want to handle. As we mentioned, this is going to be easier for you to see this operation. Since we have a 1-to-N relationship, we need to change this relationship become an attribute as a foreign key to the employee, since the employee is the N side, and then make a foreign key links to the other side of it. And therefore, you can see that employee, while we already have a supervisor SSN, we're supposed to have a recursive relationship over here. I don't want you guys to get diverted for that, so I take it away. Want you to focus on what we are handling right now. Later, we will have a slide that includes all the relationships that we create. So you can see that what we are going to do is we have this works on become an attribute, which is the DNO over here, department number, indicating which department number they are working for. So we take the primary key of the department, make it here, give a name, say DNO, and then we make a foreign key that links to the department primary key. And therefore, you can see that we have formed this relationship over here by converting this one-to-n relationship. So finally, we want to take a look of the controls. So controls, again, is a one-to-n relationship. You can see that a project controlled by one department. Each department can have several projects. And you can understand that why we need to choose the n side. Because when we come to the n side, we will, for every single project, we will have one department information. If we go to the other side, it will violate the first normal form. Why is that? Because if we take this controls as an attribute over here, indicating every department has several projects that you need to work on. So you are supposed to put multiple values in the project. And as we said, for first normal form, we cannot do that. Every variable holds only one data. That's why it has to go to the n side. Similar things for the employee works for a department. Every employee works for one department, so it's supposed to be very easy. If I have 8 employees, every employee has one department they work for, so it will solve the problem. If we choose the other side, what's happening is that for one department, I will have a box that need to handle several employees. And again, we cannot do that. And therefore, come back to the controls. What you can see is that for project, in step number 1, we get the name, number, location. Name, number, location. Underline the name already, indicating that's our primary key. To handle this relationship, we need to go create a foreign key over here using the primary key of the department. So again, the number indicating what is the department number that this one belongs to. Create a foreign key, point at the primary key of the department. And therefore, this is the step number 4. That's how we handle the one-to-n relationships. So you can see that step 3 and 4, one is one-to-one, the other is one-to-n relationships, and we can easily using these foreign key concepts to handle that. Step number 5 is different. Step number 5 is going to work on the m-to-n relationship. Before we move into that one, I want you guys to see why it is very difficult. Because every employee works on several projects, so you cannot simply change this relationship goes to the employee, indicating that what are the projects we work for. Because they may work on one project and may work on 3 projects. And that's how the first normal form will be violated. If we change this one, goes to the project, then it's indicating for one project, you have several employees who works on that one. Again, you will not be able to handle that. Therefore, a special treatment need to be created, which indicating we need to create a new table. Similar ideas to the new array at space to handle all of these works on operations. Let's take a look at that. For step number 5 is mapping the binary m-to-n relationships types. For every regular binary m-to-n relationships, we need to create a new relation to represent this relationship. Include as foreign key attributes in S the primary keys of the relation that represent the participation entities. Their combination will form the primary key of S. Also include any simple attributes if there is any. Let's take a look at how we're handling that. For the m-to-n relationship, this works on is the one that we will see is not going to be able to handle by the simple foreign key approach. So what we need to do is that we need to create a new relation called works on. The primary key of the project as one end that they attach, and the other end is the employee. So we need to take the primary key of the project, the primary key of the employee, and then forms the foreign key, go back to connects the project and the employee for us, and the primary key of the new relation that we created would be the composite attributes of the primary key of project and the primary key of the employee. Let's take a look at that. So you see that while we try to deal with the works on, what you will see that we need to create a new relation called works on. It connects employee, it connects the project. So what we need to do is that we need to take the primary key of the project and the primary key of the employee, into the new relations that we create. So we have ESSN, that's the primary key comes from employee. We have P&O, that's the primary key comes from the project. So we need to include those two attributes, form the foreign key to the two tables so that we can connect all them together. The primary key of this new relation that we created would be the combination of the two primary keys. So ESSN underline, P&O underline, so that we form a composite primary key over here. Since there is also an hours attribute attached to this relationship, so we need to include this hours over here as well. And therefore, you can see that is how we would be able to handle the M to N relationships by creating a new table. And therefore, if we just simply look what we have done about the conversion after step number 2, this shows in the end of last video, you see that we have creating 4 relations. Step number 1 creates the employee, department, and project. Step number 2 creates the weak entity, which is the dependent. So now, after step number 3 through step number 5, we have including all of the relationships among those by also adding a works on. This comes from step number 5. So let's take a look of those things one by one. While we start doing with the one-to-one relationship, we goes to the total side of it. So the department has the manager SSN, goes to the SSN over here. Now, when we try to handle the one-to-one relationship, the first one we converted is the recursive one. The next one is the one that we indicating which department it works for. And the next one is the one that says that project goes to the department. So those are the 3 relationships we have converted in step number 4. Step number 5 is the one that we create this new relation over here. That's why we have 5 relations now. Using the primary key of the P&O goes to the project, using the ESSN goes to the employee, and that is what we have seen for the conversions. We are almost there. We have converted everything, but one thing left that goes to our step number 6, which is the multi-value attribute. Let's take a look at that. Step number 6 is that we have one multi-value attribute that we need to handle, indicating that the department can locate it in multiple locations. So, like we said, first normal form, you can create one box for only one item. You cannot hold multiple values over there. In order to do that, we need to create an array-like space to hold all of those. In this relational schema diagram, we need to create a new relation to hold those. So let's take a look at this. For each multi-value attribute A, create a new relation. That's exactly what we need to do. This relation R will include an attribute corresponding to A. So we will have, of course, locations, which is the one that we want to create. Plus, in order to make sure the locations link with the primary key of the original table, we need to take the primary key as the foreign key in R of the relation that represents the entity that has A as an attribute. The primary key of this new relation that we created would be a composite primary key. Let's take a look at this. The relation department locations. So what we need to do is that because the department locations is something that we want to handle, so we create a new relation called department locations. We need a location over here. But if we only store the location, then there's no information regarding to, say, department number 1 located in Little Rock, department number 2 located in Conway. And therefore, we need to also include a department number, which is the primary key of the original entity. And the primary key of this new relation is the combination of the 2 attributes that we have created. Not to mention, this D number needs to link back to the department primary key. Therefore, this is the multi-value attributes that we need to look into. Since we have a multi-value attribute, we need to create a department locations table, have a department location plus the primary key of the department, which is D number over here. Then we need to create a foreign key that links back to the department, and therefore this is how we will be able to do the conversion. And after this step, we have everything. So you can see that we have this new table being included. So now we have 6 tables with a foreign key that links back to the department. So step 1 through step 6 is good enough to handle about 90% of the ER diagram. You may be curious, what is it that we have not covered? Remember when we were in the ER diagram topic, we talked about an unary relationship. Most of the relationships should be binary relationships. If you have unary relationships, that indicating the n things has to happen all together. And when that is happening, we need to see how can we handle that. In step number 7 is mapping of unary relationships types. Since this is also part of the ER diagram, we have to talk about it. For each unary relationship type R where n is greater than 2, if n is equal to 2, we have step 3 through step 5 to help us handle that already. So for n is greater than 2, we need to create a new relationship S to represent it. So we need a new table. Includes as a foreign key attributes in S the primary key of the relations that represent the participating entity types. In other words, if this relationship involving in 3 relations, we need all 3 relations primary key to be included. And you can imagine what's happening. All 3 of those need to have a foreign key linked back to the original one. The primary key of this new relation would be the combination of all 3 of those. As simple as that. Let's take a look at this. So saying that we have a supply, this is indicating a ternary relationship that connects supplier, project, and part. Inside of each one of that, they have their primary key. They may have some other attributes going to handle that. To convert this supply, what we need to do is that we create a new relation called supply. Take all primary key of the 3 entities that links to with them. I draw a very dramatic underlines 3 those attributes indicating that the primary key of this new relation will be the combination of the 3 primary keys. And then every single one of that will form a foreign key links back to the original one. If there is any relationship, any attributes comes with this relationship, we also need to include that attribute. So this is how we will be able to convert the unary relationship. So this is exactly what we have said. This can map to the relation supply, shows all of these things. The primary key is S name, part number, project name. I also include this slide in here to show you how similar they are about the M2N relationship. Basically, step number 7 is almost a mirror reflection of step number 5. You see that M2N relationship is doing the same thing. Create a new relation, get the primary key of the 2 attributes that comes with it, underline both of them indicating it's a composite primary key, and each one of that will map back to their original entity's primary key. So just try to show you how similar they are, and that's how we will be able to handle those kind of multiple to multiple relationships. Finally, in the end of this video, I want you guys to see this summary. If that's an entity, we use step 1 or step 2 to do the conversion. If that's 1 to 1 or 1 to n, that's the easy way of handling the relationship. So we would just simply using the foreign key approach to do that. If that is an m to n relationship, we need to have a new relation. So this is corresponding to step number 5. Unary relationships type is the one that corresponding to step number 7, which we just discussed. Simple attribute, we just make them as attribute. Composite attribute, simple. We just pick the simple components. Every simple components forms equals to the composite attribute. If that's a multi-value attribute, we have step number 6 to handle that. So we need to create a new relation, make a foreign key links back to it. The value set is the domain that we are looking at. The key attribute is the primary key that we are looking at. And therefore, this gives you a summary of what we have discussed for the first part of the conversion. At this stage, you should be able to convert every single thing in the ER diagram. In our next video, we want to talk about how do we convert the EER part, which has corresponding to superclass, subclass, as well as the union.